So this question is a linear modelling question. So we're told that Jemima is saving money to buy a car and that the price of the car is modelled by this equation here. Meanwhile, she's saving money and that's modelled by this separate equation. So in both equations, t is the time and we need to write down the amount of money Jemima saves per month. So for part A there, essentially it's asking for the gradient of the savings formula. So she saves $400 every month. If we look at that equation, every month that passes, we add another 400, and then originally she started with 2,000 in savings. For part B, we then need to use the calculator to find out how long it will take Jemima to have saved enough money to then buy the car. So to show the working out in our exam, we need to make sure that we have the graph drawn as well. So we have time is here, and then we have the savings and the cost of the car on the y-axis. So we're going to go to our GDC and we're going to plot these two equations. So we have 8,500 times 0.95, and that's to the power of, for these purposes, x, and then 400 times by x plus 2,000. So when we graph this, we'll probably need to change our settings. So we're just going to go to, window. Let's change this to maybe 20 months and see what's happening. We also don't really need a negative there. I'm just going to change that to -2 because that would be negative time, which doesn't make sense. The same with the money. But we're expecting that this car is probably going to be, quite expensive. We can see here 8,500 seems to be like a good number for a starting value here. This is where it crosses the y-intercept. So let's maybe select 9,000. Okay, and now we can see what's happening much clearer. So we have the savings where she starts with 2,000 and it's a linear increase. So this is the equation for S. And then we also have the cost of the car, which seems to be showing something like this, and starts out here at 8,500, and this is the cost of the car, C, or P, sorry, they have in the question. So in terms of part B, which was to work out how long it takes for her to save enough to buy the car, we're asked here for the intersection. And if we then use the calculator to find where that intersection is, we can see that it's at 8.64 months. 8.64 months. Now, if it's at 8.64 months, obviously she's not adding money halfway through a month. She's doing it per month. So at 8 months, there's not going to be enough, and therefore it's going to take her until 9 months. So we need that integer value to have enough money to buy the car. And then part C here at the end says, after 3 months, how much does she still need to save? So we need to find here what S of 3 is. So this is how much has she saved. And that is, we can just use our calculator even. So find the value, and we want 3. And we can see there that it's, on the price of the car, it's 7,287.68. So that's P of 3. So 7,287.68, and it's 3,200 that she has saved. If I just press the down arrow, 3,200 on the amount of money that she saved. In which case, the amount she still needs to save is just the subtraction between the two. So 7,287.68 minus, and we always leave 2 decimal places for money. So she has 4,087.68. Okay, so that's how much she still has to save to make the final cost of the car. So in terms of marks, there's 1 mark here for the answer, Then there's 1 mark for the method and 1 for the answer of 9. If you have the 8.64 or the graph drawn, either of those is fine for the method. And then for the last one, there is 1 for realising that you had to substitute into each one correctly, and then 1 for the subtraction and the final answer.